I'm happy to introduce Scott Callicutt. He flew in here from Riley, and he is currently with Cisco. He has quite a bit of experience working in the DevOps community, and today he is going to talk to you about, Scott, what is it that you're talking to about it? I didn't bring out my notes here.
Today I'm talking about pretty much my history.
Excellent. So
from where I worked.
So Scott, take it away.
Thanks. Thanks, everybody. So for this presentation to make some sense, you need to know, whereas other presentations went, here's all the things you need to know, this is great because this is just a story about me. I get to tell the story of me and the things I learned as I transitioned from different jobs. The key part is I transitioned from academics and a team that was really small to, well, Cisco, which is definitely not academics, and a team that's relatively large and spread out. And I got to see what things that used to work for me fine, don't work in the new place, things that did work for me in the small place worked fine, and they moved. So I'm gonna go over a few of the things I learned, going from a small team to a large team. Hopefully people will be able to, when you're thinking about your DevOps team building, you can go, hey, this is something we should think about if we move to a bigger team, or this is something we should think about if we move to a more spread out team. So that's me. I spent 20 years at NC State working in multiple colleges and departments. The funny thing about academics is your management and academics are academics. They're not a professional manager. So IT kind of lags behind in how it gets implemented because you have a chemistry professor in charge of the chemistry department who's in charge of the IT for chemistry. They'll hire professional people, but it's not a management-based position unless you happen to work for the School of Management, in which case they're right on top of it going, we're teaching people to go to business and manage things. So that being said, at NC State, there would be like one person for the entire College of Physical and Mathematical Sciences. That's physics, chemistry, math, all the biologies that you could throw in there. We had one person. We upgraded, we had two, and then we had a director and two, which was awesome, except for there are about 80 people just in biology that we had to support. And so we ended up with 200 or 300 professors, and that's not counting the students. So it's a little different from Cisco, because like I said, it's a small team. And because I went and saw a waterfall and made one joke, I was told I had to include this, that this is the only acceptable waterfall at the DevOps conference. Did that earlier this week when I flew in. And of course, because I work for Cisco, I was asked to make sure I put in a disclaimer saying that what I'm presenting is not necessarily the view of Cisco, nor the view of North Carolina State University, who were my former employers. Well, are my former employer in the case of NC State. So, automation. Because we had so few people at NC State, most of us got really good at automating everything, which at the time, we didn't think of as DevOps. We thought of as, I'd like to keep my job and I don't want to have to do this 500 times. So I'm going to automate it so I do it once, and then it'll do 499 times by itself. So every professor who comes in, once I get it fixed once, we can roll it out to everybody. We also refers to it as laziness in action because it is. Nobody wants to do an action over and over and over again. Later, DevOps appears, and a whole bunch of us realize, hey, a whole bunch of this automation stuff, where you check your code, you do your, we're already doing it, but we were doing it just because it seemed like the way to be a force multiplier. If you've got one guy who's doing the development, has to support all the machines, everything you can do to make their job easier is a good thing. So automation gets you lots of different things. Automation gets you faster speed. Yay, I can deploy my code faster. I can deploy my services faster. It gets you stability. If you have to type 499 times the same command, I will guarantee you there will be a typo someplace in there, and you will mess it up. You'll mess up somebody's name. You'll mess up the quota, something. So it gives it stability. The consistency is the same way. Hey, if everybody's supposed to get 500 gigs, everybody gets 500 gigs because I wrote the script to do that. Efficiency is a thing. And of course, all the other good stuff that comes with it. The problem with automation, when I moved to Cisco, this worked great when there was only one of us, because when there's only one person or two people, everybody knows how the automation works. You go to Cisco, your team is now 40, 50 people. People have different sets of responsibilities, but they're all working on the same stuff, so they have specialties. So somebody writes the automation for you, and you think it's great, and it's awesome until it breaks, and they've gone on leave for some reason. My example for this is we had a great automation that we're like, every time if it breaks, hit this button, it'll delete everything, and then redeploy it. It'll come up in seconds. And we did this multiple times. And we didn't quite, I mean, for us it was magic, hit the button, make it, okay, it works. And it never came back quite right. We eventually got hold of the person on vacation, and the comment was, oh yeah, after you do that, go in by hand and change the scaling. And we just kind of looked with a look of, you told us it would always work. Well, yeah, because I run that script, and then I go by hand and scale it again, and I was like, thanks. That was an automation fail. Thank you. Yeah, we need to fix that. Please fix that. So when you're doing your automation task, when you're thinking about a larger team, now, and this is true of smaller teams too, because if only one person knows it and there's only two of you, and they're out, you're going to end up with the same issue. It's a bigger problem when you have multiple people working on multiple automations and chains. Somebody's not going to know how it works, or they're going to barely know how it works. The people that know how it's work are out. They're off to a conference. And it comes back to bite you. So think about your automation. Make sure that when you have people, they can leave notes. It's not that everybody has to know it. It's just that everybody has to be able to learn it and follow through. And if there's notes that go, do this, do this, do this, hey, by the way, run the automation and then scale it, that's what we'd have done. The notes were, run the automation. So that's what we did. GitLab, GitHub, Git whatever, whatever you're using for your code repo. It doesn't really matter. Most of these will apply to them. So I was at NC State, since I was the only one who wrote the code, strangely, all my commits had things like boo turkey as the comment, or it did a thing, or whatever I felt like typing, because the only person who would go back to look at those would be me. Going, well, that was Friday at lunch. I was fixing this. The comment meant nothing. So when you go to Cisco and you submit 500 boo turkeys into your code, it's funny until they do a code review and then go, hey, we're not quite sure what you did. I mean, we can see the code, but we can't follow what it did. So make sure you use useful names on your branches. Make sure you use useful names on your comments. It doesn't have to be super specific. It's nice if it's super specific. At least I was working on etcd and fixing this. Then they know, oh, okay, that's what's happening. The small scope actually bites us to this day. Most of my code, well, a lot of the code that I check in are Ansible roles that I've written. And to deploy an entire platform. And so I'll be editing the code and see a problem, and I want to fix it. That's the natural reaction of everybody who sees a problem. Oh, well, I was looking at this, I found that. The problem is, if you keep going out of scope of your branch that you built, it gets really hard to merge everything back together. Because you go, oh, well, I fixed it in that branch, but that feature's not done yet, so we haven't pushed it to master, so it doesn't exist yet. So I now need to go to the master and edit it. It becomes a problem. The simplest solution, and I have beat some of my guys every day about this, is if you find a bug, create a new branch, push the bug, and submit it. It's fine. It could be one line. I don't care. It seems kind of weird, but keep on branching to push it back. Because if you start making a branch get really wide with what it fixes, it gets really hard to merge. And it gets very hard to merge when the people on different continents doing things at different times. Because you may not be the only person who saw the bug. So then we end up with two fixes for the same thing in two separate branches that don't say they fix it, but say they're for a feature. And then you overwrite the changes when we all merge them back if they don't notice, oh, he fixed it this way, she fixed it that way. The remove branches not in use is a very simple one. When you're working with people all across the place and you say, I totally have a fix for that, I pushed it to this branch. With lots of people working and doing small scopes, you end up with lots of branches. And sometimes the branches sound similar, so people end up working in one that, oh, that was an experiment, it died. Sorry, I meant to remove it. I didn't think anybody was going to use it for anything. That's why it has become, hey, it's Friday. You should clean out every branch from your source code that you're not using. I mean, if you need to archive it, that's awesome, that's fine. But mark it in some way. Put work in progress, retired. Mark it so nobody else will jump on it going, well, that's where you fixed it. And we're going, no, that was an experiment. It failed. We fixed it over here in version 3. You're editing version 2. The part about actions not being mixed with config is something that will help you a lot, especially in the case if you're deploying something like Ansible. I write Ansible roles to deploy to multiple Kubernetes clusters that build the cluster. Those clusters are of different sizes and have different names and different IPs. So by having the config outside of the code, I write the code once, it does the thing. It knows how to dynamically grow up and down. That's fine. And then I have a configuration separate. Occasionally, we have mistakenly, in checking in our code, overwritten a configuration change because they're in the same space. Not meaning to change the configuration, meaning to, hey, I updated the code. It does the right thing now. Oops, I didn't notice that we changed the configuration and I overwrote it because I didn't think we need that extra branch because it didn't look like we needed it. So that's one of the things that we learned. If you can separate the two, keep a copy of both. If you can separate them, then you're also guaranteed when you're troubleshooting, is it a configuration issue or a code issue? What was the change? What change did we make before the issue showed up? And if we go, well, I ran the Ansible stuff, I'm like, well, then it can't be the configuration. It's not changed in 7 months. Maybe the machine died, in which case the config is wrong for some reason, but it's not that someone changed the configuration and that caused us an issue. The other thing GitLab or any of the Git repos give you is you can automate tasks. It goes back to automation. With all these people typing, they have different configurations as far as what they like to see. But if you lint the code so that it's all linted when it's turned in, it makes it easier to read. Most of the time I can validate the code going, would this actually deploy correctly? I don't know if it'll do the right thing, but it does do a thing, and it will do it. And you can even deploy the code. We have some of our items set up to do, hey, if you make the configuration change, I'm going to see it, I'm going to deploy, which is what ideally at some point you want to do. But before you deploy it, you want to make sure it looks, people can read it, it does the thing that you think it's going to do. You can actually throw in another one going, I test the code. For us, that's more of the validate is the test. Time zones. This seems like the world's easiest thing to fix. It's not. It's great if everybody's in Chattanooga, you have a time zone. The time zone doesn't change. The time is constant. Yay. If you work for Cisco and 2 of the people are in Belgium and the monitoring team is in India, you have multiple time zones. And when you say it broke in the morning, it means different things to different people. We have done this before. Belgian guys, it broke in the morning. I'm like, no, it was fine. And they're like, our morning, not your morning. Okay, let me look now at 2 or 3 a.m. of my time. Oh yeah, it totally broke, sorry. Also, when you're doing your logs, if you have multiple time zones and you're doing jumps between summertime and not summertime, your logs will have times, and it sometimes confuses people, especially if you're in Europe, where they will have a time zone change, just like we do but it's on a different week. It's off by 2 weeks, if I remember right. It makes it confusing in the logs at that time of year. The rest of the time, you're fine. The simplest thing we do is everything is UTC, yay. If you use Graylog or something like that, Graylog will ask you what the user's time zone is. You can put that in, and it will display the logs with your time zone on them adjusted by using the UTC. And that way everybody can go, in the morning, my time, or hey, at GMT this happened, or UTC this happened, and we can all find it. It also helps for compliance later on. So if there's ever a question of when someone did what, you can, if you all use UTC, then you can all say, well, you know, I was called at this time, India called me here. And when we run down the list of what we've done to fix a problem, we have the full list of this is everything that happened, this is when the machine saw them, and this is when we fixed it. This is actually how my groups are spread out. We have, I'm in RTP. There are some people in California. The machines live in Texas. Part of the developers are in Belgium, and the monitoring team is over in India. Which is really fun when you do WebEx meetings with everybody, because somebody's going to lose. Somebody's going to have to call in from home. It's just, we're like, okay, who is it this week? You know, you're either up early or staying late. So like I said, time zones. Log time is important. Monitoring time is important, because if you're monitoring for metrics, you want to make sure that, hey, we all know when this happened, so I know that I made this change, this metric changed, that's what caused it. Summertime, like I said, is a big issue. That's just, in Europe, they go down to summertime about I'm pretty sure it's 2 weeks. Can't remember exactly. They always tell me when it happens. So now we're going to talk about metrics. We monitor our software a lot. We want to know when it breaks. We want to know when someone deploys. We want to know when someone ran something on it. In my case, the application I'm talking about is actually, I build a platform that other people write code on to use as a platform. So I will get errors that are, they wrote their code wrong. I expected that, but it's not an error for the platform. It's a, you wrote your code wrong. I have to weed those out from my platform broke and did not run your code. So metrics, you have lots of metrics. And that's the point. That's one of the weird issues we have from when you move to a bigger group. People fight over which metrics are the important metrics to measure. And that's because people have different metrics that they care about and others that they don't. In my case, I care about the Kubernetes parts, like, hey, when did someone deploy something? Because if I'm in charge of the platform, I care about that. If you write a microservice that runs in there, you care about, hey, where are the logs from my microservice when someone ran something so I can see if it's broke? Where's the performance from my microservice? In the case of large applications, the amount of metrics can be overwhelming. I had been asked once I should record all the metrics. It lasted about 45 minutes before I had a phone call of, you can stop recording all the metrics. You will run us out of disk space. Because we had an allotment, and I was like, okay, I'll turn them all on. Click. Oh, that's cool. Yeah. And I was having a great time looking at all the metrics, thinking it was great. And then they were like, yeah, stop it. Stop it now. We have to keep those for a long amount of time. We don't need all those. So metrics are an important thing. When I was at the university, strangely enough, metrics were only used by me. They were used by me to make sure the platform worked. The users did not care. It was up or it was down. There is no in between. The service is there, the service is not. That's what you have. My machine works, my machine doesn't work. In the case, as you move to business, it may be, was it up? Was it fast? What's our response rate? Things like that. You need to know on your metrics what you measure and know why you measure it. I have a good example of this one. 4 weeks ago, I got a phone call about my load balancers were all busted. They were all running slow. This is causing our code to run slow. This is an issue. Users are impacted. Fix it, fix it, fix it. What did you change? And the bad news is I looked back and said nothing. They have not changed. Let me look. 8 weeks. No one has changed the configuration. They've just been there doing their thing. Nobody's made a change. We spent 2.5 days with our metrics saying it's the load balancer before someone went and noticed, We weren't measuring the payload size of one of our API calls. We only measured how many times it went off and was it successful. And at that point, in our testing, somebody went, let me go see. Measured the size and went, let me go back to the old version. And then they showed up and said, hey, so the payload size increased by 150,000%. That might be why your load balancers are slow, which was my answer of, you should probably fix that. And we should probably not be blind to that in the future. And they were like, yeah, we've never measured it before because it was so small. And I'm like, surprise. New metric, measure the size. Only need it for troubleshooting. And that was one of the reasons we missed it. You would only ever need that if you needed to troubleshoot it. No one thought it was something that was important to measure. The important thing to measure was, did you talk to it? Was it successful? It had been so small in the past, the size was irrelevant. It wasn't something we uploaded or downloaded. We didn't care. So that's why you need to know what you're measuring and why you're measuring. Because if you know what you're measuring, you can go, well, maybe the size changed. Like I said, it took us about 2 days of, what changed? Nothing changed. Let's give it more CPUs. Same thing happened. Give it more CPU. Okay, I got nothing. Oops, come on, there we go. This is actually the most important part of this talk when you're talking about moving from a small group to a big group. You have to think about perspective. Not everybody can do everything. In my case, I'm in charge of the platform, and I do some coding. There are other gentlemen and ladies that do all the coding and very rarely touch the platform. They know enough to write a deployment. They're all happy. But if it's a Kubernetes problem, like, send it to Scott. If it's a Python problem, you send it to somebody else. That leads to people having different views about what's important in your platform for metrics, or what's causing the problem, or what you need to do next. Currently, in our environment, and by our environment, I mean on the web, whether in your data center, there are multiple ways to fix problems. For instance, in those load balancers, I could have fired up 70 or 80 load balancers and it would have taken the load, and we would have been happy. Except for now we're paying for 70, 80 load balancers for something that really was, hey, just change the code, make it not send the payload. It was never supposed to send the payload to begin with. It'll go back to a smaller amount. And I will admit, we will fight. You will fight for what you think is right when you're trying to lay out your design, when you're going through when you're doing a stand-up, going, nope, this is the thing we need to fix next. Everybody needs to take a step back and think about the other person. I have to do it all the time. My Python developers, they're important. They will write a beautiful microservice, and they're like, it's awesome and it's great and it does everything. And the only issue is your platform kills Mongo, and I talk to Mongo all the time. And I'm like, I don't kill Mongo on purpose. I kill Mongo to upgrade it, right? I have to reboot the machine. So it's going to happen. But as far as they're concerned, I am the evil man who kills Mongo. And once they realize I'm not killing it to stop their code, we have to do updates. I've got a cluster. You should use the cluster of Mongos to talk to them, and you should make your code reconnect to it if it loses a connection. Because if it goes down, it's only going down for the machine reboots. One or the other two will become primary in a minute, actually less than a minute, few seconds. Yay, and you're back up and running as long as your code does that. So occasionally we have to have the talks where we stop back and go, what's important to you? What's important? What do you see? Okay, well, I see this other thing. That's going to give you your best application in the end. That's going to give you something that you can use, ideally to either provide a service to a customer or give an application to a customer that does the thing you want to do. More importantly, by doing that, you may find things that are hard for someone else to fix because they can't fix it in their code, that you can fix easily on the other side, whether it's platform or the other side of the microservice. So we spend a fair amount of time occasionally, every 2 or 3 weeks, just going, stop, What do you see? What do I see? And let's see if we see the same thing, because normally the answer is I see one thing, they see something else. Our boss, who would be reality, comes in and goes, yeah, but what we really have is this. And sometimes the boss is wrong too, but most of the time it's what I need is this. I need a work in service. Like I said, when I worked at the university, just me. Do whatever I want. I didn't have to think about the only other perspective I had to think about in my development cycle was me. When do I want to get it done? This is one of the key takeaways for this talk. So, click. I have to get credit for the slides. My wife works as a librarian, so I actually cited the graphic. Hang on, I gotta show this because this entertains me. The sample graphic from Grafana is cited. They get credit, which is an awesome thing. Does anybody have any questions they'd like to ask about moving from one to the other? You don't have to, that's fine. So the other thing is, this, like I said, this is my little story of how I moved from academics to not, and well, it's time for you guys to go make your own story. I mean, if you have any questions, I will be here later today. I can answer questions. If you have questions about Kubernetes, I can totally answer questions or make stuff up about Kubernetes because I'm really good at that. And then, like I said, that is part of my actual job is to run a platform or build platforms for Kubernetes for Cisco. If you're curious as to what application I work on, if any of you have ever sent in a call to a TAC engineer and they have told you to grab all the logs and send it to them, my application processed those logs automatically for the TAC engineer before they did anything. When you sent it into the TAC engineer, I scarfed them, I grabbed them, we ran a whole bunch of code against it. The TAC engineer looks at it and goes, ooh, I see things broken or not. I build the platform that code runs on, or I maintain the platform that code runs on currently. So, okay, that's it.